Assalamualaikum and good day everyone. My name is Arya and I will be presenting our case study titled Composite in Sport, Enhancing Performances in Athletics and Safety. And so this is our theme for this project. For this, sports equipment was mostly made from wood, steel or aluminum, heavy, solid, and sometimes can be dangerous if it hits you. But today we have something much cooler, which is composite materials are made by combining two or more different materials to create something stronger, better. Basically the Avengers of materials, strong alone and unbeatable together. In athletics, composites like carbon fiber and fiberglass are very popular because they are lightweight but extremely strong. This helps athletes run faster, jump higher, and train longer without getting tired too quickly. So in short, composites don't just make athletes faster, they also help them survive training.
Definition of composite material. Combining two or more materials with different physical and chemical properties creates a composite material. The purpose of a composite material is to improve the properties of its main materials. The majority of synthetic composites combine flexible, high-tensile fibers with a matrix to create a rigid structure that gains the metric material compressive strength. The final result is a material that is strong, rigid, stiff, and bend tolerant. Now, I will talk about three main types of composite material. First, we have polymer composite. This is a matrix of epoxy or polyester reinforced with glass or carbon fiber fabrics. They have a high strength to weight ratio, so they are stiff, lightweight, and resistant to wear. You will find them widely used in aerospace, automotive, marine, and of course in sporting goods. Next, we have ceramic matrix composite. Their matrix is made of silicon carbide, aluminum, boron carbide, or carbon, reinforced with strong fiber like silicon carbide, carbon, or alumina. They are very resistant and more durable than unreinforced ceramics. You will often see them in bicycles or extreme sport equipment. Metal matrix composite use metal like aluminum and magnesium, reinforced with carbon fiber or silicon carbide particles. These are also widely used in automotive, aerospace, and sporting goods.
Okay, so now we'll be talking about the background and history of composite in sports equipment. So as history dictates in ancient texts, sports could generally be said to be one of the fundamentals of human civilization, since it started from being solely for honing survival skills into a full-on organized competition for health, entertainment, and social bonding. During the ancient Greeks' reign, that includes events like running, wrestling, discus, and many more. Over time, more advancements are sure to be made for its equipment as humanity progresses towards the future.
So now I'll be explaining the chronological order of how composites started being integrated into human civilization. So before the 1900s, generally speaking, sports before the integration of advanced composite material in sports, human civilization opted for a more natural composite material that includes wood containing cellulose fibers reinforced with lignin, and bone and leather. In the 1930s, during this time, the invention of fiberglass was starting to take shape when James Slater accidentally directed compressed air at molten glass in 1936. It was finally commercialized and eventually became fiber reinforced plastic (GFRP) with resin in the late 1930s, although it's mainly used for aerospace and marine industrial application. Not until the 1940s, the application of fiberglass can now be used in sport, majorly in fishing rods, skis, and sporting poles. With this new addition to sports development, it offers greater improvements such being more lightweight, better durability, and increased flexibility compared to traditional composites. In the 1960s, around this time, fiber pole vault poles were starting to be introduced, making a huge impact on athletic performance. This introduction was groundbreaking for sport equipment because its elastic energy storage offered greater vaulting heights. In the 1970s, the carbon fiber composites were on the rise in the sports equipment usage. Although its initial purpose was for aerospace applications, this is because carbon fiber can provide a significant high strength to weight ratio and superior performances. Some of the examples of sports equipment using this composite is tennis racket, bicycle, and early running equipment. In the 1990s, sports equipment are increasingly improving as new inventions are discovered and allows for more refined specific designs for different applications. Manufacturers were focusing on optimizing stiffness control, shock absorption, and energy transfer. Some of these improvements can be seen in track bikes and footwear. Subsequently, in the 2000s, following the improvements in carbon fiber for the last decade, it has now become mainstream with the addition of computer-aided design, CAD, and finite element analysis. At the same time, materials are now able to be engineered for specific directional stiffness, vibration damping, and energy return. Examples of sport that involves this improvement at the time include cycling, tennis, hockey, and golf. Up to 2010s until the present day, In our current era, we focus more on hybrid composites, with our main focus being energy return propulsion, injury prevention, and biochemical efficiency. Some of our breakthroughs were running shoes with carbon fiber plates and responsive foams and prosthetics used in Paralympic sports.
Firstly, let us take a look at the applications of composite material in sports. Composite materials are widely used in sport equipment manufacturing because they allow equipment to be lighter and stronger. For example, composites are commonly used in rackets for sports such as tennis, badminton, and squash. These materials help improve swing speed and control. In addition, composite materials are used in athletic footwear, strength training machines. They are also found in weightlifting bars, benches, and other gym equipment where high strength and reduced weight are essential. Next is flexibility and sport gear. They are used in joint support devices such as flexible braces and orthoses, which support natural movement without adding excessive weight. In rehabilitation settings, composite-based equipment helps improve flexibility, balance, and movement control, aiding recovery and injury prevention. Lastly, in strength training and exercise machines, composite materials allow customized stiffness and strength profiles. This enables high-performance weightlifting equipment to be designed without relying heavily on traditional steel construction, resulting in lighter and more efficient machines.
Now, let's take a look at some real examples of sports equipment that use composite materials. The first example that we have here is carbon fiber bicycle. The model that we have here is Trackmadon SLR. This bicycle uses a carbon fiber composite frame. It is very lightweight and stiff, which means cyclists can ride faster and waste less energy. The second example is composite basketball backboard. The model that we use is Spalding Arena Pro. This basketball backboard contains a carbon fiber plate that increases energy return. So when the ball hits the board, it bounces back faster and more accurately. So the last example that we have here is running shoes. Next is Nike Zoom X Vaporfly Next Percent. So these running shoes use composite materials to make them strong, lightweight, and able to reduce vibration. Fun fact, these shoes were so effective that some marathon runners broke world records wearing them.
Let's discuss the benefits of using composite materials in sports. One major benefit is enhanced athletic performance. Lightweight yet strong equipment allows athletes to move faster and perform more efficiently. Another benefit is reduced muscle fatigue. The lower weight and improved energy transfer reduce physical strain during prolonged training or competition. Composites also improve comfort and control by damping vibrations, which enhances grip stability and overall user comfort. Finally, the shock-absorbing properties of composite lower the risk of injury by reducing stress on joints and muscles. Next, the advantages of composite materials refer to their inherent material properties. Composites have a high strength-to-weight ratio, meaning they provide strong mechanical performance while remaining lightweight. Their mechanical properties can also be tailored, allowing stiffness and flexibility to be engineered for specific sports application. Another advantage is vibration and shock damping, where composites absorb vibrations more effectively than traditional metals. Lastly, they also exhibit high fatigue resistance, enabling them to withstand repeated loading without rapid failure.
Alright, let's go through the challenge and limitation of composite material. Firstly, we have high cost and complexity. Composite use expensive materials like carbon or aromatic fibers, and making them is not simple. For example, autoclaving, that's curing under high pressure and temperature. It is very costly and takes a lot of time. So basically, high cost can limit access to high performance sport equipment. Next, it's difficult to recycle and costly repair. If a composite part gets damaged, it's much harder to fix than a metal part. Sometimes you need special techniques or even a complete replacement, which again is expensive and slow. This can obviously affect the safety and reliability of the sport gear. The third point is hidden damage. Cracks or internal separation inside the composite are not always visible. That means the equipment could look fine but actually have damage that compromise its strength. This is why it's important to inspect high-performance sport equipment regularly. Finally, fatigue failure. Over time, with repeated use, composite can weak. This repeated stress can eventually lead to fatigue failure.
So we have come to the end of our video of case study. We can summarize that the composite materials are a crucial part in enhancing athletic performance by providing equipment that is lightweight, strong, and durable. Aligned with the advancement of technologies, sports equipment can be said to be further enhanced and procure enhanced athlete performances, improve the safety and injury prevention, and provides better durability and ergonomics in the future. Despite all the challenges, Composite material will undoubtedly continue to mold the future of sports through ongoing innovation and material advancements.